Welcome. Let's get started. Happy Thursday. It is amazing how this is the last meeting in February that we've got. Some announcements. So the next optional sections we've decided to move to after spring break rather than beforehand. I suspect, and I'm sure you will agree, especially after you take the midterm exam, probably there will be not a lot of extra energy to attend optional sections. So we've decided to move those. Those will be run by Katya. Those will be after spring break rather than beforehand. We'll release the 2019 midterm on Monday for your perusal and discussion afterwards. So we do have an answer key which we may release at a later date, but we're going to give you the exam first, and then we can talk about it, especially a week from today in the review session in class next Thursday. So the plan is new material today and also on Tuesday, and then a review in class on Thursday, and then on the following Tuesday, March 10th, the exam in here in class, the regular class time, 12:40 to 2 p.m. And if you have a DSP accommodation but have not received an email from me, please check your email, and if you can't find that email, or if you just feel like getting in touch quickly, please see me after class or email me or something. Any questions about the next several class meetings in the midterm? Well, I'm sure you do have questions about the midterm, but I'll go ahead and let those percolate, I guess. And so if you do have a question about the midterm, you can ask it later in class if you have formulated it by then. That's cool. Lab 6 is due next Wednesday, March 4th. We'll monitor that and see how folks are doing. If you need an extension, we'll consider that. I think it's best to get it done before the midterm review, but we might have it due on Friday instead, depending. So we'll be flexible with that, but the due date is Wednesday, March 4th. And it's hard, so please get started. Questions about Lab 6? So Lab 6 is due. Lab 5, you're on your own to do. You don't need to turn anything in for Lab 5. We'll look at it again today, at least part of it. It's about population projection with the Leslie matrix and the age structure that emerges over long periods of time. Okay, so do just stop me if you have a question. So there have been some questions about how grading will happen, and so I wanted to say a few things about that. So I think I'm reiterating some points I've made earlier, some points I've made with students one-on-one, and so I need to revisit those and say them to everybody. So we curve around to B, and that means that the mean and the median grade will usually be about some flavor of a B. We curve the exam grades and the overall course grade, which is, of course, it consists of these components. So the labs are 20%, the iClicker participation is 10%, and all those go into a total score that then we take and we look at the percentile distribution of that, and we grade on a curve. We anticipate that the exams will be difficult, so that the average score will be something more like maybe 60% of the points rather than a very large percent of the points. So the curve will typically help you in terms of your overall outcome with the grade. So we're sorry, but we don't have extra credit opportunities formally, but what we should maybe rebrand as extra credit in some sense is visiting office hours. So the lab scores, let me just start off with what the usual perspective might be. What's a check plus on a lab? A check plus helps offset a check minus you might earn on a different lab, or a 0 that you might earn on a different lab if you have already burned your 2 free labs. So the lab scores stay within this 20 percentage points of the overall course grade that's assigned to the lab. So they won't help you anymore. There's no extra credit that arrives from any of that. So I would please, again, just treat your lab scores as you're keeping up with the class. There's really no point to asking for regrades to get more points for those sorts of things. They won't affect your overall course grade beyond the 20 percentage points that you get if you do all the labs and just do them. So I wouldn't spend one's time looking for more points there. If you are in need of help and feel like you want extra credit, then you should please come to office hours in section. And I really mean this, because the most valuable thing is to have students come to my office hours and reveal what is unclear. That is so important. That is the only reason that I make you guys have iClickers, because it helps me a little bit in getting a sense of what is unclear. It's much easier to do it in office hours. So That's why there is a reward for coming to office hours, and that is, suppose you come to office hours before even, and maybe you still bomb the midterm even having come to office hours. If you bomb the midterm, but you come to office hours, especially after having bombed the midterm, we take that into account if you show progress and dedication. So to the extent you could call something extra credit, that's what it is. If you cannot make it to office hours, try to stay in touch over email or talking before or after class, making it clear that you are dedicated and working to improve your mastery of the course material will be reflected in your overall course grade. Questions about extra credit or any policies I just mentioned? Okay, moving on. Again, I'm very impressed that you all are here on such a beautiful, beautiful spring day. It feels to me like the air conditioning is on in this room in February, right? That's where we are. It's a lovely summery day practically out there. But if you're like me and you suffer from seasonal allergies, you know it's not summer, it's actually spring because everything's blossoming and you're sneezing and you're itchy all the time. That's my life anyway. So what are we going to do today? I wanted to touch on the latest in the continuing saga. It's like a soap opera, really, of the coronavirus. We can still laugh about it now, and I hope we will continue to be laughing about it in the future. But of course, there are many reasons to be a bit more sober. We're going to wrap up the math and the simple empirics of age structure, looking at some stuff in Excel, maybe a little bit, and also in R. We'll talk about the life cycle saving perspective and the creation of transfer wealth, and that, in shorthand, is Social Security in the United States. Other countries have different names for their pension programs. In our country, we call it Social Security. Next time, we'll talk about the demographic transition, and then the time after that, the midterm review, 1 week from today in class, and then finally the midterm exam on Tuesday, March 10th. So the saga continues. So following the CDC warning that was on Tuesday that I mentioned in class, there was a presidential press conference on Wednesday, and I was impressed. I had very low expectations for what was going to happen, and so I was thus impressed. There is going to be some reaction by the U.S. government, and luckily it is not fitting the pattern of some of the other unlucky countries with governments that have been really rather bungling with the whole thing. It's not probably on top of things as maybe where the government needs to be, but at least they are aware of it and they're not denying it, which is a big step forward, I think, in many ways for this country and also just generally for the response to this sort of thing. So the Vice President, Mike Pence, will head up the coronavirus response, which, at least there's somebody in charge of it. I mean, that's what you can say about that. There needs to be somebody in charge of these sorts of things. And there actually was this history, which is, it's true. It actually was a coronavirus that was apparently located, their origins were traced in the Middle East. That's the ME and MERS. So he got 50% of the national cases were in Indiana when he was governor. Later, and this is right after the presidential press conference, the CDC confirmed that in California, and this is in Solano County, which is just across the Sacramento River from here, so it's not that far, there was a confirmed case of what, up till now anyway, is what's known as a community spread case. Unknown contact, well, what should we say? We know that the things spread, through sneezing and, maybe shaking hands, but, airborne, that sort of thing is probably the way it goes. We don't know for sure, of course, with coronavirus, but the problem is that this individual was diagnosed with it and screened positive, and the precise source, namely like foreign travel or contact with people who had been traveling abroad, was unknown up to now. Now, the problem is that you have to try to reconstruct the history of travel for individuals, and they may not remember it or be able to self-report, and they may not tell you whom they've come in contact particularly accurately. So who knows how this will all change, but that is certainly sobering. Yeah, what can we say? I'm quite confident that UC Berkeley will absolutely be on top of this. I think they've demonstrated a very good track record of being on top of these sorts of things in the past. So I would not personally be that concerned about it, but I would definitely be aware. And like we talked about last time, wash your hands often. Get moisturizer if you have to for every time you wash your hands. Some of it goes down the drain. You got these crabbly hands that feel like they're made out of stone or something. But please keep washing your hands and think about contingency plans if big meetings like this maybe sequestered. You never know what might happen, right? And I think the first thing to go probably be the big lecture hall things here at UC Berkeley if a change were to be made. So just think a little bit about what you might do. And the good news is I think most of you, if not all of you, do not have little children who you would have to then bring home like I would and take care of them because the schools are closed potentially in some future outcome. So it's a wild time. There's always something like when in teaching, whether it's the Great Recession. I mean, that was, I think, arguably a lot more scary than this. I don't know. These mystery diseases that harm us certainly are frightening, but it is true that coronavirus is kind of a lot like the flu. It's not that big a deal for most of us, but that also doesn't mean that it's not a big deal at all. It just means that we're probably not all going to drop dead of the flu. So we just need to think about being prepared. Questions, comments? Yeah. Oh, about the midterm, okay.
How important is information in the readings that is not covered in lecture?
The question is, how important is information in the readings that was not covered in lecture? So it's still important, but the metaphor I usually say here is that most religions have a couple of things going for them. Usually there's a preacher person in the actual house of worship, and that's the equivalent would be me. I'm not trying to say anything about my standing here, but I'm the person who actually translates the word of the deity into the congregation, right? And then we have a discussion. There's also a holy book, right? So all those things are there, but what's kind of most front and foremost? It's the person in front of you, and so it's the things that we talk about here in class. That's all fair game material, but I wouldn't spend a lot of time reviewing the readings. A lot of them are very dense, right? The Holy Scriptures usually are quite dense if you ever sat down to read them. That's also true about academic works, too. So what's your first step? It's office hours, it's class, right? It's seeing the GSIs, seeing me, Piazza. And if you're unsure about something, then check your texts. Other questions? Okay. Okay, so learning objectives, and here I'm not sure I did a very good job in the slide, but this came up in office hours. It also came up after class on Tuesday. What is the point of calling it my father's riddle? And it's a subtle one. It's, does a population with low fertility get older and older and older and older and older and older? Well, that's sort of half right. The population will get older, but it doesn't keep getting older and older and older and older, which is, I think, a fairly subtle point. So there are kind of two things here. One is that a population with low fertility gets older, and that's kind of the first level of things, and I think that's intuitive to most people. The point, and why the thing is called the riddle, is that you would think, well, if you have low fertility, aren't you just sort of, going to be getting older forever as a population? And it turns out, as we see in Lab 5 and in the math that we saw last time, that's not the case. That in fact, there's a stable age structure that we converge to. So the population doesn't get older and older and older. It gets older, and then eventually it sort of stops getting older. So that's the learning objective. Separate from that is this other part of it all that, you might wonder, well, what is happening to rates of fertility and rates of life expectancy, if you want to call it that? What is happening to fertility and mortality in countries? And of course there, the answer is a little bit more subtle or more detailed. It's not as simple as you've got a stable schedule of mortality and a stable fertility rate. Then what happens? Well, it turns out the population age structure also becomes stable over a long period of time. So that's another kind of point here as well. Another takeaway, though, is that if you have some kind of low but positive population growth via fertility, so it has to come via fertility, at least in the model here. And in the real world, it could come through immigration. We'll talk more about that after the midterm. So if you have low but positive population growth, you're going to have an age structure in the Goldilocks zone. This also came up. Well, how do you know what age structure is the best? What is the Goldilocks zone? And so in astronomy, right, the Goldilocks zone is just being just far enough away from a star that you have liquid water, which we think is required for life. And here, what's the Goldilocks zone in age structure? I guess we don't really know, and there are trade-offs here. But if you have a whole lot of kids or a whole lot of seniors, that in either sense, presents a real challenge for the working age population. So there's probably a Goldilocks zone of age structure where you have a decent rate of fertility producing a decent number of children who then grow up to become workers. Of course, in the future that's helpful. But not so many children that you are just overwhelmed taking care of the children. I think that's one way to make it intuitive. And also, you don't want to have so many seniors that you're taking care of the seniors all the time, and we'll see the math about that later in today. So immigration also helps to save out population aging, but obviously fertility does, and that's one of the big takeaways here. Okay, with life cycle saving, and we'll get to that, I think given the amount of stuff we've got to go through, we've got an hour still, but we might cut rather short this point about the population projection matrices and kind of motor on to do the life cycle saving stuff, which is pretty darn important. And you know, this is obvious once we look at it, and if you've looked at the slides, you know, it'll be obvious to you too. There are periods in the stages of our lives, there are periods in our life, aka stages in our lives, when we are vulnerable and not producing enough to survive. The obvious one, of course, is our youth, when we need our parents to shelter us and provide us food, and we wouldn't know the first thing about doing either of those, let alone getting ourselves dressed, etc. You know, wiping our bottoms, you know, all sorts of things that you know, parents of small children are very aware of, and that's a sort of obvious. With humans in particular, of course, we have a very lengthy period of adolescence. In rural and more primitive human societies, the period of adolescence usually is much shorter, and we'll see that in the data, that maybe by about age 10 or so, perhaps a young human might be able to go and help produce food for the family, working on a farm or hunting and gathering or something like that. I suppose probably not hunting, but you never know. So that's part of it. Then the other side of it, of course, is what happens when you get into your older years. And of course, to some extent, you know, modern societies have to grapple with this because of the benefits of mortality or decline, that we are living much longer than we used to. And so there are so many of these life years spent in elderly periods when you know, hunting and gathering certainly is sort of off the table, and a lot of other economic activity is also rather off the table physically, and you might not want to engage in any economic activity if you don't have to. That's one of the big stories about modern societies, is that it's really nice to just retire and say, all right, see ya, and drop the mic, right? Just leave. Just leave and ride off into the sunset and enjoy time with your grandchildren. Well, if you do that, you either have to have a family who will support you, or you'll have to have private assets like a bank account or stock holdings. But you know, heaven help us too, as the coronavirus rages on. I think one of the biggest casualties is probably going to be stock prices. And you know, for you and me, that's not that big of a deal. But for people about to retire, that definitely is a big deal. That's sad. Certainly not as sad as the human casualties, but still a casualty. So those are the two big stories. The life cycle means that you've got these periods of vulnerability, and when you're elderly, you know, one might say, well, actually, I'm not vulnerable. I've got a bank account full of what exactly? Well, it's money. Okay, money's fairly stable, I guess. Stocks. Well, what are stocks? Stocks are claims on future dividends paid by corporations. They're usually based on future profits and all that. Well, what makes corporations profitable? People who demand products, also people who produce products. So in your older years, you know, you're actually dependent on workers and consumers still, as though they were transferring resources to you directly. We just happen to call it stocks, owning stocks and other financial instruments. So it's a claim on some, you know, cash that's flowing through a marketplace, but ultimately it comes from people who are younger when you're old. It's pretty easy not to find too many people who are older than you when you're old. It's like, well, everybody else is younger. Well, that's right. And a lot of the people who are younger are working, and that's why there's value to stocks. So we'll be moving into that coming up. But first thing I wanted to show you this. So this was, I got a really good time looking at the responses here. So if you recall in the iClicker questions, we're going to look at them in just a second on the next slide. I asked you about technically the ratio of these two survivorship probabilities. So script L is the survivorship probability of living to this age that's in the argument. So script L of 20 means the survivorship probability of living to age 20. And here what I've done is I've taken, and the GSIs will probably laugh at this, but I've taken cohort life tables from the Social Security Administration. That's one problem. From 2005, that's another problem. So there are two big problems with why this might not be a particularly good estimate. One is that they're from the Social Security Administration, and they have a fairly lengthy history of having a particularly signed bias on their forecasts of longevity. Namely, they end up being too pessimistic about what human longevity looks like. Now, in the interim, we've learned about the opioid crisis. So it's possible that this might not be that bad for that reason, that this emergent threat of mortality at midlife seems to have emerged, and the emergent threat that has emerged in the meantime. I just mangled that sentence. But so Social Security, that's one problem. The other problem is that the forecast is from 2005, and of course there's much water under the bridge now. Still, you know, this is a decent baseline, and it actually gives you several decimal points to play with. And so here's the story for the cohort born in 2000, which is roughly you guys. 99% then have lived to age 20. So there is, you know, 1% mortality of 1% deaths, basically, cohort lack of survivorship along the way. For males, it's a little bit higher. And I think probably what that reflects is adolescent deaths in, say, like, you know, motor vehicle accidents and things like that. It's possible it could also reflect early, I think we would say neonatal, right? So post-birth, right, neonatal, right? Isn't that what that means? Where you've been born, but the mortality rate first out, I think, is higher among boys. Okay, L75 is what you would see then following all the way out to age 75. Technically, what I'm asking about is the ratio. So it's about the same, right, especially for women. It's a little bit different for men, a whole percentage point there. I guess it's also a whole percentage point for women. I mean, that sort of makes sense, I suppose, given what's happening here. But you're dividing it. It's the conditional probability you've lived to 20, so you're answering the question, and you're looking at what these, what this is. And so you ought to be telling me this ratio of them, the probability then given that you've lived that far. So, how did you do? You know, not bad. I think what's interesting here is underestimates. Now, I mean, you know, you might say, well, look, come on, you asked me about this in extremely sort of roughly, you know, big categories of, I think it was 50, 60, 70, or 80, or 90%, right? Those are big, different things, and I wasn't allowed to say something like 75% or whatever it is, the truth, but you know, you'd probably round it. And it turns out that this is kind of the way these things usually go, that people usually underpredict a little bit. So one thing one might say, save more. You guys should save more because you're going to be living longer than you think you will on average. That's one upshot here, and that's, I think, a pretty sort of deep and meaningful thing to say. What else is interesting here, though? Folks basically got the male-female difference right. Now, the absolute difference is quite a bit larger here, right? It's more like 7 percentage points, and here it's only about 2.5 percentage points or something. But the male-female split was realistic, right? It's qualitatively showing that women live longer than men. They do. Okay, so now, does everybody want to see the next slide on smoking and vaping? So there it is. So looking at both sexes combined, and suppose I compare the two groups, people who say, no, I don't smoke and I don't vape, so you have to reply no on both of those. And here's yes, smoke or vape, so either one. And it's a small difference there. So health economists love this stuff. So people are aware of this, right? That is what we are seeing here. Now, it is also true that in this sample size, you couldn't reject the null, that there is no difference. That's true, but the point estimate still reveals something deep here, which is that people are aware that smoking is a lot of fun, but it's not real great for longevity, right? I know that. It's fun. It's just, you know, it's not that great for longevity. Questions about this so far? Yeah. What is this? This is the average response. So what is the 72.1%? It's the average response to the question. Maybe I should just show it to you. So I asked you last time, what do you think the probability of living to age 75 is? And let me just pull up the slide here. It's back a bit, I think. There we go. It's this one, right? So it's the average response. So people had to choose one of these, but they're going to choose the one that they think is most right for them. And then the average response is meaningful. It's the same kind of thing about an average survivorship probability that's measured using demographic rates, because it's taking everybody and it's figuring out what the average survival is. Yeah. So it's not quite the right number. It's a little bit below, but the thing is, what showed up in the way students replied here reflected the sex difference. So women on average reported 3 percentage points more, or something like that, of survivorship probability. And also this popped out too, right? Kids don't smoke. Smoking kills you, it's true. Okay, or the other way of saying it is to get it out of your system now, right? Do it now. Smoke now, don't smoke later. Just to tie this up, the alpha omega here is that, the thing about the coronavirus, right, we talked about earlier, at least in China, we don't know a ton about the deaths elsewhere yet. In China, it was men who were older, who had usually a big history of smoking, and thus weaker lungs. They were the ones who have been dying from coronavirus. So smoking does a lot of things, and of course you can get lung cancer, emphysema, and all that, but it also weakens your lungs, and you might be more prone to die of pneumonia or something. Kids don't smoke. You guys are like, whatever, dude. Okay. The other thing too. Oh, here's the smoking, vaping, just to show that this was interesting, because we were sort of wondering about this. So if you smoke, probably you also vape. I mean, it's about half and half. So there were, right? I mean, slightly more, I guess. It was common to see somebody who did smoke and vape also. More common to see somebody who said no to cigarette smoking, but yes to vaping. So like 11%, and then 81%. That's the most common responses. I didn't do either one. But this is one of the big questions: is what is this? This group here that does both. Are folks trying it, or do they actually continue to do both? Or is vaping actually a substitute for smoking? In which case you would have imagined seeing like people here, but then also people here, and nobody here, if they were perfect substitutes. But they might not be. They might be complements. You can vape marijuana. So yeah. So if I say vaping, people might say, yeah, I vape. And so what you're saying is maybe it's people who are smoking cigarettes, because that's what we asked about. Although I guess you could say, well, is it a marijuana cigarette? We never call it that, right? We call it something different. And I also vape pot. And so you could be in that group and doing that. Yeah. Yeah. I think then what will really do your head in is that the long-term health consequences of marijuana smoking are not well understood. I mean, there is some pseudoscience out there, but smoking, because it was so widespread and widely reported, and at the earlier eras, it was definitely not at all stigmatized. Not at all. It was the reverse, right? If you didn't smoke, you were a real weirdo. We know kind of a lot about it. The problem with pot smoking is that we do have some surveys that ask about it, but it's not something that we have real good data on, I wouldn't say. Okay. All right. Here's a whole bunch of numbers. I'm sorry, I just take a table out of an academic paper, but what it shows is that these are people who are older, who are 50 through 62, and we look at their subjective survival compared to a life table value. So a 67% survival probability is what this number is here, compared to a life table value of 68%. And so these men never smokers actually kind of understood fairly well what this would be. And then this researcher did this amazing job of trying to figure out what the life table value of current heavy smokers would be in this age range. And it is just astonishing what this is. Kids don't smoke, seriously. Or get it out of your system now. Do not smoke when you're age 50 to 62. Because this is what pops out of the life table, that the survivorship to age 75, I think, to age 75, so age 50, about my age or so, further on. I mean, look at that. It's like a third of the probability. It's a big time effect. So what popped out then was that they were aware that this was an impact, but weren't that realistic about how just great an impact it was. So this 0.501 means that male current heavy smokers knew that their survivorship probability was lower, but they didn't get that it was going to be this much lower if they were heavy smokers, which is a bit sobering. And so why do health economists love this? People are smart, but they're not that smart. People are smart. They're aware of this as a problem, but I mean, and I don't blame you, right? I don't blame anybody. I don't blame myself for when I really don't know the basic statistics underneath stuff. Of course, that's hard. I wouldn't know what they were. I'd take a guess or something. But it seems like there are these systematic sort of underestimates of exactly what smoking is going to do to you. Wild stuff. Okay. Questions about that? So again, all that's private. It's for class purposes only. We won't publish it. We won't use it at all. I just thought it was really compelling. If it's compelling to you, come and talk about it in office hours. Yes?
Most of those vaping tests currently by black market THC.
No, nicotine one. So the statement was about so harms caused by vaping and what sort of products get vaped that cause harms. And you're saying it's black market THC? Is that what you said? Yeah. Not nicotine based ones. Yeah. And that's right. Yeah, I should have phrased it differently to try to get the sense because we don't. I don't know. Is nicotine and marijuana, are those complements? I don't know. Are they substitutes? Anyway, deep questions. Yeah. Okay. All right. Population aging. So let's do some of this again. And I'm trying to think about how to kind of refine this. Or here's Japan. Is this going to continue? Is Japan going to continue getting older and older? Yes. That's the thing that we saw last time with the old age dependency ratio forecast. In fact, it's going to get worse there. It turns out, though, that the formal demography then, and this was the picture that I dazzled you with, and we've talked about in office hours. And so let me say, too, so what are you on the hook for understanding here? We go on these journeys of symbolic math and pictures, and it's to try to stimulate your thinking about the world. You don't have to be able to regurgitate these elements on an exam, but we do expect you to have been paying attention and asking questions in your own head or maybe on Piazza about what this all means and why. So I hope that helps. On an exam, I think what we might do is talk about the shape of this, which is the survivorship schedule, relative to the shape of the population age pyramid, and they are related. And you could think about this as, we're translating the shape of survivorship, which always kind of looks like this kind of thing, through whatever fertility gives us in terms of the population growth rate thing into this. So if you've got very rapid population growth rate, you've got this orange schedule, and that gives you this bowed out pyramid over here, sort of amplifying, if you will, what this looks like. If you've got negative growth, you get this thing that produces this football shape. So an older population, very few younger people. And the way to make this intuitive is, so we're talking about the population growth rate, which comes from fertility. So if you've got high fertility, you're going to end up in a situation like this orange curve here, a lot of babies. If you've got, and that's what this is telling you, it's a positive population growth rate here. If you've got low fertility, you're going to have a negative population growth rate, and it's going to get you this half of a football kind of thing. So I anticipate there's probably still a lot of confusion about that. And do please ask us in office hours and in the review session, and now too, if you have a question. So what are we doing with matrix projections? So we've got a way of writing this down from linear algebra. And in our example, it's going to look like this, where what we're starting with is a sort of a 60% net reproduction ratio, I think, from the age group number 1, which is the 0 to 19-year-olds. So they're going to produce more 0 to 19-year-olds at this rate, 60%. So 0.6 times whatever this thing is the next element in the top row. That is the contribution. And then plus 0.8 times whatever this guy is, which I think I've written here on the next slide. Right? That's what this is telling us. So 60% net reproduction ratio of these folks, plus 80% of these sort of middle-aged prime sort of fertility folks, end up being the new entrants into the population, the young people next period. And then here's a survivorship story. So there's 90% survival from population age group number 1 into the middle age period. And then there's 70% survival of the middle-aged folks into old age. And of course, what's survival for the old age folks? 0, right? They're dead. Boom. It's a rather an abrupt kind of fall off here, but the ski slope, like I was narrating, you're up here at 1, 0.9, 0.7, and then you're down to 0. So that's survivorship underneath it all. Okay. So you might say, what in the world are we doing? Why are we doing this? And the answer is that you can do this in a spreadsheet, but linear algebra reveals some patterns, some magical things that we wouldn't maybe otherwise be able to see in a spreadsheet. When you're searching for a stable age structure, and I hope I've done the math of the eigenvectors and eigenvalues right here, what you're trying to look for is a situation where this is true. So you've passed a population vector to this matrix A, and if this is an eigenvector of the matrix, then what you get back is an eigenvalue times the eigenvector again. And here, our eigenvector lambda is e to the n, where n is the average annual growth rate times tau, the number of time steps. So, and this is a little different. I think I've not uploaded the latest version of the slides, but I think I had written this a little different. If you're looking at the slides right now, this is just to remind us that if what we're looking for is the average annual growth rate n, which is a number in the example that's about 1%, you have to take the log and then divide by tau, 20, the number of time steps in this example. Okay. Okay, well, I think I'm snowing all of you, but, or I think about half of you are fully aware of what we're doing, and I'm snowing the other half, and I apologize for that. It's, it's formal stuff which tries to get across these learning goals. So what are we doing and why? How matrix multiplication takes account of births and deaths in an age-structured population. Leslie matrices are a long-time tradition in demography, and they served formal demographers very well because there are a lot of these insights that can come out of the eigenvector decomposition, basically, and other things that you can do too. So constant age-specific rates produce a steady state or stable population. Here I want to say one thing that occurred to me. A lot of things in Econ 175 and a lot of things in Econ are all about equilibrium, reaching a steady state. And so the riddle is about that also. Just like the Malthusian model is about reaching this steady state with the iron law of wages and a stable, constant population at that point, just like the Solow model is about a steady state in which saving per worker and depreciation per worker are equal. And it turns out that gives you a steady, stable growth rate of everything except output per worker stays constant over the long run, but the number of workers is rising, output is rising at the same rate. This gives us this same kind of story. Right, so the analog is that in the Solow model, you've got the saving rate and the population growth rate. Those are constant, and if you then also have a constant depreciation rate, you get a steady state in which things are stable and unchanging. Here, in population projection, we've got steady mortality and steady fertility, and then it turns out that you have, in the long run, stable growth at a constant rate, which is the eigenvalue, with some logs and all that, It's the eigenvalue, and then you've also got a stable age structure. And it's deeply counterintuitive if you look back at the father's riddle, right? The intuitive thing would be, well, if you've got low fertility, you're just going to keep getting older and older and older and older. And it turns out that's not true, that you reach this steady, stable state. Too many words that start with ST right there. So that's one of the learning objectives here. And so the lab steps through this in R, where there are a bunch of nifty things that multiply matrices together, and here's a whole bunch of great symbolic math. And so I think let's try to run some of the numbers here. Okay. I want to see my little green arrows, there it is. Okay, here's one. It's my little green arrow to run something. Okay. So what this is showing then is the first step of Here's our A matrix. Does that look familiar? It's a little hard to squint and see the R code here, of course, but it's the same thing as we saw. Let me back up, I guess, when we're looking at this. It's our A matrix here. So the fertility rates are along the first row. That's the only place the fertility can show up. These are the survivorship rates that are here in the second row, first column, and the third row, second column. So back in R, that's what the matrix looks like. And here we're just picking this out of a hat. Let's suppose our starting age vector is this: 50 people in the age 0 to 19 group, 30 in the next one, 20 in the next one. And here's our matrix multiplication code right there. So A times P0, and what do we get for P1? And the answer is this. Now, it's a little easy to see, given, of course, that I've zoomed in so much. It's maybe easier to see once I go back over to Excel and show you this. Here's what we just got out of R. So it's at time 20. What happens with this initial age vector with the matrix applied to it? The other problem, though, that emerges is, and then here I've just, through the magic of Excel, just taken this code and just copied it right over. That's just so fun and great, and we can see it all. I think one reason why the linear algebra is revealing, though, is why? Well, okay, we've got these numbers. What's happening to the numbers overall? Are they shrinking, growing, or staying the same? They're growing, right? Now let me ask you this. Can you eyeball the population age structure up here? If I asked you what proportion of the population was aged 40 to 59 in this cell, could you tell me the answer? Can you divide 175.5 by 34? I guess. It's hard for me to do it, and that's part of the magic of the population matrix exposition, basically, is to help you think about the eigenvector look of all this. So here are the age structure proportions, if you like, the shares of these different age groups in the total. And now let me, through the magic of Excel, copy this over there. And so we're going to see this in R also. For me, I guess I kind of like just seeing all the numbers here to begin with. It's not quite the same, right? The age structure is fluctuating around a little bit. But one of the really nice things about R is it will let us apply this thing a whole bunch of times. And, I guess we could basically just do it up here, couldn't we? Why are we doing R? The other thing, R actually, so Excel and R are extremely good things to know about for your future careers. Probably Excel a little bit more useful, I don't know. But R is extremely useful, especially if you want to do something in data science. How many people actually, had you seen R before this class, like in econ? Yeah, many of you had. Had anybody seen Stata? Some of you had, yeah. I'm trying to think of what else is common. So R is kind of sort of taking over the world, I would say. So to me, R maybe is a little harder to look at least in the zooming that I've done here, and I guess I could probably take this out of there. That might help. The beauty, of course, of the R Markdown language and all that is you can make a notebook that kind of keeps all your notes in one place and makes it a little bit clearer. I also just kind of like personally seeing the numbers. And I think the first job you get out of Berkeley, you might find that your bosses just like seeing the numbers in spreadsheets. That's one big element there. But also your bosses might tell you to go and do something equivalent to forecasting population with matrices, and you might do it with R because it's much more powerful for doing stuff like that. All right, so here's our annual growth rate. Oh, I haven't clicked through everything I needed to up here. All right, so this is the ratio of the sum of the population in P0 to the sum of the population in P1. So it's telling us that this is this, it's the coefficient right now. It's the total growth that we're getting. It's not really the equivalent of the eigenvalue. And then if you want to take the annual growth rate and compute it, it would be this code right here. We're calling this new variable R0 to 1, and it's the log of the ratio of these two population values divided by the number 20. Yeah, that's always kind of deeply counterintuitive too. Just as a side note, so when you get into calculating growth rates in your future careers, I think you will find this to be an exasperating challenge like I did, and many of us do. Do you calculate growth rates with logs, or do you do it the old-fashioned way where you take the ratio and subtract 1? And I guess I'm surprised that we haven't crashed like more moon landings with that problem. Usually if like something crashes on the moon, it's an issue because somebody was doing English units and somebody's doing metric units. But the other way that you could screw it up is getting growth rates wrong and calculating percentage changes either with logs or with the traditional way that we do, and they're different, and that'll come up again. So the next thing we might want to look at is whether the age structure changed. And so one thing you could do is look at the proportions in each of these categories then as a share of the total sum. And so let's click the green arrow there. And we see next to, so these are the population vectors, 50, 30, 20, 45, 54, 45, 21, hike. I'm not playing football. Okay, and so what you get is what we've seen over here. The changing age structure, percentages, and the big question is whether these things settle down over time. Okay, is there an age structure that we can project that will not change? Let's try. And so the other thing too is that, let's see, within here, okay, so this is our symbolic math. And what we're trying is this particular population vector. But the other thing to try would be, if I get it right, would be something like, what should we call it? The p-eigen, I think. And it's the eigen formula, eigenfunction rather, of this matrix. So that's one thing you could do and look to see how this compares with all that. Now let's run this guy, and are we seeing the proportions changing? Not much. So here's where we started with this educated guess, which is going to be the eigenvector basically, or a scaled version of it. And next to it then are the proportions in each of the age groups, and so, right, the proportions are in fact just, the eigenvector divided by 100 in this case. Kind of a clever way of looking at it. And then this is the next level of population, and it gives us back basically the same age structure. Okay. So we've got 30 minutes left. I think I'm going to stop there. I'm going to point out that if you're interested, at the bottom of this, the application that might be useful is to think about, suppose you were to transfer into this world. So we had a world in which the NRR of this first group was 0.6. Suppose what happened was that fell in half. Suppose what happened to the NRR of the second group, the age 20 to 39-year-olds, is it fell even more from 0.8 to 0.3. What happens? Why do we care? Historically, human populations have gone from high fertility situations where people have a whole lot of kids to lower fertility situations. And you might wonder, well, what does that do to age structure? So the nifty thing is I can just ask you, what does fertility decline do to age structure? And you should be able to say right now, it makes the population older, right? That's sort of obvious. And that's what this can show you. The other question, of course, is just how much older it makes it. And when you reach the stable age structure that is older, you won't get any older. That's the riddle of my the riddle of my father, the riddle of Josh Goldstein's father, which is a clever riddle. Questions about this? Should we look back at the learning objectives? Why are we doing any of this? It's linear algebra, which is a powerful tool. It's nice to see it and actually see a use of it. I mean, so when I said last class, I said, who just absolutely detested linear algebra? Part of my problem with learning linear algebra, I definitely did. They never tell you what it's good for. Here is an application. And I get it. You're a math teacher and one is teaching math to people and you're like, well, look, I got to get through this stuff. The point is you got to see an application or else you're just not going to care, right? Here's an application. There are many others out there. This isn't the only one, but it is a very useful one, especially sort of the history of the field of demography. It's a useful one. So how matrix multiplication can do this, and it takes account of births and deaths. You get a steady state that pops out of this, which has this connection, this analog then to the other models that we've been looking at. In the solo model, you've got a constant saving rate, you've got a constant rate of population growth, and a constant depreciation rate, and so you get a steady state there. Here you also get a steady state in terms of stable population shares. You still see growth, you might not, but most of the time, and in this example you do. And then stable populations have these constant exponential growth rates. It could be 0, but here it was positive. And if you do the example at the bottom and step through it, you might find something different altogether. Questions? Okay, should we do an eye clicker? Okay. Yeah, so the key is, which of these will always be true? And do please discuss with your friends. Okay, so let's close polling in 3, 2, 1. Let's close polling. So I think the best answer here is A. That's the point of the stable age structure thing, the riddle of my father. Okay. Yeah, I'm pretty sure that A is always true. If you've got low but stable, in other words, it's not falling further and mortality is also fixed and there is no immigration, then this will always be true. The population will get old and stay that way. And you might wonder, well, what do I mean by get old and stay that way? It's describing what the population shares look like. So the oldest age group has a stable population share, and it's large, but it stays that way. So C and D could be true, but we don't know for sure whether they are. They could be. And B is definitely not true. That's the riddle of my father thing, right? So it's not the case. And so E probably is also not the right one. Questions about that? So I think the best answer is A. Yeah. How do you know if population will decline or increase in size? That's a very good question. And so my response is exactly. You don't know. And that's why it's not the right answer here. Yeah. That's a very good question. What additional information would you have to know to know whether C or D is correct? And you could answer it in a number of ways. You would have to have your R studio lab. You could look at it and just project it. You could look at the level of TFR, the total fertility rate, for example, and make a guess about it. It kind of depends on what mortality is, though. I mean, you could have very high fertility, but also really high mortality. It depends how they are relatively, So it's an open question. Okay, let's do the next one. If fertility produces a growth rate that is close to 0, then the population age structure will look like what? Okay, so this is a really hard one. So let's wrap up polling in 3, 2, 1. Okay, so I think the best answer is D. And E is also probably a pretty good answer. Okay, so we're all over the map on this. I'm sorry. I think this is hard material. I was talking about it with the GSIs before class. And we will think long and hard before we put anything like this on the exam because it's hard material. I think D is the best answer because of the model that we had in the slides. So if you look back at that, then you will see we're ending up with the survivorship curve if you've got this zero population growth rate. How would you make that intuitive? I'll need to work on that. The way that you answer the question, which is like, SAT strategy, right? Because these are multiple choice questions, and how do you answer the question, is by ruling things out. So looking like a rectangle or a straight line up and down is a strange structure. You would have to have survivorship that looks like that, and that's very rare to have. You're always going to have tapering at the top because people eventually have to die. There are going to be a few that make it through up into these very advanced ages, but generally speaking, you always see this tapering. So A isn't, so that's another way of looking at it here, what to rule out. A is not correct. Looking like a traditional pyramid with a flared and wide base tapering to the top. The flared and wide base part gives it away. That's not correct, because if you get a flared and wide base when you've got very rapid population growth with high fertility. I'd have to think about that a little bit. That if you had high enough mortality, would you find that still? I'll think about it some more. So this is a hard one. It's meant to reinforce that the symbolic math that was nifty would reveal this kind of thing. It gives you back the survivorship curve. There's a reason why population age pyramids kind of look like survivorship curves turned on their ends like that. And so let me think about the intuition. Let me get back up. Having bamboozled you, do you have questions about this before we move on to life cycle saving and age structure ramifications? Yes. Yeah, I think that's exactly right. So her question is, would C, the football shape, be more correct if fertility rates are so low that you get a negative population growth rate, right? Yes. Yeah. So the way to make that intuitive is that you get, if you got really low fertility, you're going to have negative population growth. And that's also going to be consistent with having this football shape where there just aren't as many kids as there are working age people. They're not reproducing themselves, right? That's the thing. Replacement fertility is about 2 children per woman or 1 child per dyad, if you think about it. So it's the male and female sides reproducing themselves. Yeah. Okay, other questions? Yeah, this is extraordinarily unfair, right, this question. I wrote it last night. I mean, one does one's best to sort of do a eye-clicker question to kind of keep everybody awake, but it was clear that was extremely hard. So that question, I promise, will not be on the exam. That specific question will not be on the exam. All right. Okay, the life cycle saving dilemma here. The life cycle saving dilemma. The life cycle. It sounds kind of like a product, right, for fitness. Buy the life cycle for only $19.99 and you will be set for life. Okay, so you've got dependency here when there are consumption needs in your childhood, but your production is probably 0 for a rather long period of time, and who knows when it starts to rise. There's a surplus when you're working, or at least one hopes there will be. For most people, there is. Because the thing that I think about that makes me sleep better at night, right, is that a lot of our transfers to children in the form of childcare are actually this. So even though we might not be saving money, at least we're actually transferring in the form of spending on childcare costs to fund these guys down there. And then here, when you're old, usually your production tapers off, and so one needs to fund it some way. So this is a nifty graph of exactly the same kind of thing, where we're looking at within Côte d'Ivoire or the Ivory Coast different trajectories here, depending on whether you're urban. So that's the dashed line here, and so the income levels are much higher, as you might imagine, in urban areas. That's kind of the traditional story with development. Consumption is also higher in the urban areas. That's the dashed line here. But in both cases, more, I think, strikingly, so there's this big deficit here in younger ages where the consumption is higher all the way up through, I guess it's 25 to 29, exceeding income for folks. And then here's this big surplus area, and it's a bit of a different story in rural areas where there still is consumption in excess of income down here, but it starts to taper away and is gone by 15 to 19. So if you're in a rural area and you're young, you are producing by age 15 to 19. So different levels of development, different structures of all this, but still the unifying thing is the divergence between production and consumption over the life cycle. I guess the other thing to say would then be, what's happening up here, and income tapers off. People are still, I guess, being productive and working. I guess maybe the more striking thing is that so urban folks in Cote d'Ivoire were also at older ages were also producing in excess of what the rural folks were doing, but consumption in both places was still higher. And you could do that, of course, if you had a bank account or stocks, or a family who would take care of you, or a government who would take care of you. In the United States, here is the story in data from, I think that says 1987. This is an older paper by the guy who used to teach this class, Ronald Lee, and a co-author, Tulja, who's down at Stanford. So I was in Tulja's lab, and also in the biology department down there is still the great Paul Ehrlich, whom we learned about several weeks ago. Still, I believe, teaching, although it's possible that maybe they're both emeritus at this point. I'm not sure. We're sort of getting to that age. Here's a story about Amazonian hunter-gatherer societies. I think I'm beating a dead horse here at this point. It's similar. A net deficit of consumption in excess of production for these ages. And I guess the surprising thing to say about this is the Ache, who live, I think, in Brazil or maybe other, I'm trying to recall exactly which country that is. But just how long, in fact, the deficit persists in this society up until age, I guess, 25 or so, which seems quite a ways for a more primitive society. So how do you solve this dilemma? It's got to be either private transfers, public transfers, or private saving. And in order to have private saving, you've got to have some ability to invest into durable goods. There's got to be some technology that actually facilitates this sort of thing. So there are all kinds of ridiculous metaphors that economists come up with, and we're going to use some. You could think about this as if you are able to produce chocolate, but you have a refrigerator. You could keep the chocolate for a while, and that is this way of saving for future days. And I mean, right, it's just sort of a preposterous idea, because what happens to chocolate in the fridge? It just gets eaten, right? I mean, it doesn't stick around. But the idea there is that chocolate, if you don't refrigerate it, goes bad after a while. And of course, even that's a little questionable. If you don't have physical goods to store value, you're kind of stuck here. So in primitive societies, this is a real problem. In modern societies, of course, we have all sorts of physical goods. We're in one of them. We are using another one, and many of you are also using them. We have all sorts of physical goods that you could transfer your surplus into by purchasing a claim on it or actually owning the thing outright or whatever. And then the thing stores value, and the market could give you something in return for it later. Chocolate, I guess, something like that. So now let's just kind of step through some math of what sorts of things we might be talking about here. So suppose we've got two different stages of life, separated by one generation. And suppose there's no mortality, nobody dies until the second stage, old age, is over with. So everybody who is in middle age will get to old age with perfect certainty. And the goal, suppose, is perfect smoothing of consumption. And by that, we basically mean equalizing it. So back here in the picture, of course, consumption is not exactly the same in different life periods. And of course, the other thing to point out is that this is actually a period measure of this. So we're comparing young people today with old people today, and you might see something slightly different if you looked at somebody over his or her or their lifetime. That's true. So it might not be perfectly flat, but it's kind of reasonable to say, well, consumption is kind of flat. And so I think here the stylized pictures maybe back here. Maybe you would, I don't know, in the depths of your middle age, when you're trying to struggle to support these guys and also these guys, you might spend a little bit more also on yourself. And then maybe you spend less on yourself as you get older because you don't have to. I don't know. You're happier, right? Hopefully. There actually is work that suggests that's true, that childbearing age parents are the people who have the lowest subjective well-being of all age ranges because you have little children. Okay. All right, so suppose we've got a nut economy with durable goods. So nuts can be stored, that's the idea. If an individual then who has this sort of lifetime production, that's what the blue line is. Suppose you produce a bunch in your middle age and you think about saving a bunch of nuts to eat when you're older and you're not nearly as productive as squirrel. Maybe you take 6 of your nuts from when you're producing 18 while you're in middle age, and you squirrel them away, and you take, you put 6 away and you eat them with your 6 that you produce later. And so your consumption over your lifetime then is this smoothed level of 12. Now, the problem arises, so that's all well and good. I mean, given a couple of things, right? So if your nuts, they can't decay, but also nobody can steal them, right? That's important that they actually are there for you when you want your nuts again. And that's not clear that that's always going to work out. So you need to have stable government. The other thing, though, the government might be useful in doing is setting something up like this. So suppose you've got a chocolate economy, which is this hilarious metaphor. You produce chocolate, and the point of chocolate is that, so chocolate does go bad. Of course, to know that it goes bad, you have to actually not eat it long enough for it to go bad. Nobody ever does that, so that's kind of a silly thing. But that's why we call it a chocolate economy. There's no way to store the stuff. There's no refrigerators. You have to eat it or you lose it because it goes bad. What do? Well, there's no technology to transmit this thing ahead 20 years in time. It's chocolate. It's going to go bad. And so what you could do is the people in middle age say, look, I've got 18 chocolate bars, and the oldsters only have 6 chocolate bars. And so I can say, look, I'm going to give 6 of my middle-aged chocolate bars to the oldsters. But I'm going to require, in some way, I'm going to strike a bargain with the next generation to do the exact same thing for me when I get into my old age. So if you can strike that contract and it's enforceable, and that's kind of a big if, then you're able to do this sort of thing. You get to transfer chocolate to the oldsters. They benefit. They're like, thank you so very much. And you're like, no problem. Just make sure that your grandchildren do the same, right? So the oldsters say, hey, no problem, but then they die. And then you're left hoping that your children are going to say, hey, oldsters, guess what? I've got 18 units of chocolate, and I'm just going to go ahead and give you 6 of them in exchange for the belief that my children will give me 6 units of chocolate when they are middle-aged and having grown up. And so that's the problem here, is that there has to be some way of enforcing this contract, and it's called government. You can't actually strike the private contract with people who are going to die, right? The oldsters are going to die after you give them your 6 units, so you're middle-aged. You're like, here's 6 units, and they're like, great, see ya, and then they die. So they can't really enforce the contract. You have to have something else that does it. That's then the motivation for government getting involved in providing this transfer system, which we call a public pension. Now the next, let me just stop and see if there are questions about that part, right? So this is rather critical. A pension is a way of transferring resources without having durable capital goods from productive middle-aged folks to old folks. Okay, so then the next question is, what role does population growth play in this? And the answer is going to be that population growth is very important for a system like this. If you've got a pension system that is transferring resources from current working age people to older people, then a higher rate of population growth means that you've got a younger age structure. That's one way of thinking about it. You've got more entrants into the labor force who are then paying these taxes that are then redistributed to old people. So let's suppose we compare these two worlds in which there are 200 middle-aged people per 100 middle-aged versus the same size. And if you work out the math, the punchline then is in this world where you've got population doubling each generation, you've got a higher smoothed level of consumption for both of these birth cohorts, and in fact for everybody as long as this contract can be enforced. How does that work exactly? It's because each time a transfer needs to be made up the age range from working age to old folks, there are more working age people if you've got this kind of age structure with the population growth rate. Okay. So how many people have heard the term Ponzi scheme? Yeah. You will hear this remarked, that in a traditional Ponzi scheme, the way it works is that somebody, who's originally, the guy's name was Ponzi, promises to pay investors a very, very high rate of return and finances that by getting new investors. And so there is some parallel there, it's true, with a system of public pensions and Social Security in the sense that The new investors here are the next generation and the generation after that. And the trick is you have to keep signing more and more of them up. This is what Bernie Madoff went to prison for many years for doing. You have to keep sort of chaining people along, and that allows you to pay your earlier investors these ridiculously large rates of return and all that. So it is similar to that. The thing is, at the end of the day, the difference between a Ponzi scheme and Social Security is that could be a stable system provided that you have sustained population growth and a government that is around to actually enforce this contract. Another way of saying this too, it's a way of formalizing what otherwise might be a private familial contract between generations. It doesn't have to be so nefarious like a Ponzi scheme is obviously something that nobody really wants part of. But you'll see that mentioned sometimes. Okay. So here's another iClicker question. We've got 8 minutes left. Why don't we do this? In a chocolate economy with no saving, if you have higher population growth, does it A, increase the gains to intergenerational transfers, or does it not affect the gains, or does it decrease the gain to intergenerational transfers? Do please go ahead and discuss with your friends. Okay. All right, so why don't we close polling in 3, 2, 1. Okay, so I think the best answer here is A. Higher population growth increases the gains to intergenerational transfers. Some of the words I heard suggest that perhaps people were confused by what in the world intergenerational transfers meant. It means moving resources in this example from people with surpluses, working age people, to people with deficits. It could be children or it could be retirees. And if you've got faster population growth, children actually are going to be more expensive, but retirees will be cheaper. Yeah?
What seems to be like the proportional difference between like the baby boomers and Gen X and millennials? What seems to be that?
I'm sorry. You're wondering about the size of these different generations, right. The baby boomers and Gen X and the millennials and things like that. Oh, that's a good question. I don't know offhand. I mean, sometimes the age range, they're different widths. Yeah, the years of birth are not all the same for all those groups. Yeah.
Is it? I was just kind of wondering this like general size. Is it like double? Or is it like how many?
Well, baby boomers were very large compared to the earlier generations, and I think they're large compared to younger cohorts as well. I mean, I think a demographer would say, what you want to look at is the old age dependency ratio, which abstracts from this issue of kind of exactly when you were born, but it looks at age ranges that are salient, which is working ages to retired ages. And there, the trend is very clearly toward higher dependency ratios. Yeah. And it's because of fertility declines. But as we will see later too, immigration rates help offset this. Okay, so we've got 5 minutes left. Let's do a few more of these. Suppose we've got a chocolate economy with positive population growth where there were no transfers. Who gains from starting a system of transfers? Okay. All right, so let's close polling in 3, 2, 1. I think the best answer here is E, that everybody gains. Okay. So the current generation of old definitely gain. Maybe, I guess the confusing thing there is we sometimes refer to a windfall gain as almost like a lottery that you win. And so I think A is a good answer, actually, and now upon reflecting about this, because they gain more than others. So that's true. Why? And it's because the current generation of old, if the system starts, they didn't actually pay into it, but they get the benefits of it. So E, I think, is still probably the most true because by selecting A, you're saying other people don't gain, which is not actually true, provided that the system functions. But I like A also. Okay, we definitely have class fatigue, don't we? let me just talk you through this next one instead of subjecting you to it. Whoops. Okay, so who gains from ending a system of transfers? I think the best answer there is that nobody really gains from ending it. Now, so this is getting at this political economy of Social Security and of pension systems. The thing is, of course, it's a little bit more complicated than this because if, and we go back a couple of slides here, I'm sorry, did I have two 11.4s? I did, I'm sorry about that. Suppose you have higher population growth, that increases the gains to doing this. The problem is that if population growth falls, then the gains to a pension system also decline. So the gray area then comes in, supposing you thought of system of transfers, if you thought about ending it, that would hurt everybody, but maybe the stress on working age populations is pretty high if population growth has fallen. So that's the subtlety. We'll continue this next time. Have a great weekend. Thank you.